All right, we are the Gantry Actuation for Moon Gravity Simulator. This project will be simulating gravity for one of the lunar rovers by applying tension proportional to 2/3 of its weight upward, so it would only have 1/3 of its weight on the floor, thus allowing it to have better preparedness for lunar missions. My name is Joe Bedford.
I'm Dan Curran.
I'm Karan Gupta.
And I'm Kamal Diolis.
Basically, our project's task is to basically build a giant gantry which has 2 axes, to purchase the motors, to figure out what torque and specifications we need, and make it fast enough to be able to quickly respond to the robot's actions down on the ground. This gantry needs to move at about a velocity of 1.5 meters per second, and for reference, it's basically the length of that table per second. It's very, very fast.
One of our big motivators is the fact that there is actually a demand for a gravity simulation like this, both with a purpose and for the novelty of it. It can be applied to not just rovers, but people go to an amusement park and go into a gravity simulator. So we're trying to do it in a very cost-effective manner. And that demand is a large part of why this project is necessary, in addition to the fact that it will also greatly help our personal lunar missions to better analyze low gravity situations.
By mid-semester break, 5 weeks from now, October 15th, we plan to have completed SolidWorks model of all the parts and its construction. We would have selected and chosen the designated parts we need and specifications from online vendors, and begin warming up the online vendors for long-term processes and long-term buys. Like motors would take up to 4 weeks to deliver, so we want to order them before mid-semester break, so we have them for December, so we can assemble a full working model. And by December, we should have a full working bench test of this gantry, this 2-axis gantry. It will not be structurally up and ready to go on the market just yet, but we'll be able to test all the working parts, see it actually in action, respond, and perform, I guess, on a bench. And in spring semester, halfway through, this project should be completely completed, so we're going to make preparations for that next semester. Any questions? Yes.
Do you have a target for the maximum payload? Should you have lost that?
The maximum payload would be 300 pounds, which is the maximum for the robot.
300 pounds total, or 300 pounds removed from the mass? Eventually.
Total.
It's interesting. It seems like that's the tension that you'll apply in the cable.
It's a commercial, so the goal is to use a commercial balancer or lifter, and that's going to be able to be set to whatever object is in the area of the gantry for this simulator.
And it's that device that has a capacity of 300 pounds.
Yes, the great one.
Great. So it is the cable tension.
Will you be able to deal with like a rover going on a slope, so that the angle of tension would have to be
It would always apply to constant tension, so it would be able to balance the rover on a higher elevation.
We're actually targeting to focus on the center of gravity. So even though the rover tries to overcome obstacles, even then the center of gravity will remain the same. It's like a conical concept.
What were the dimensions of the entire structure?
The dimensions of the entire structure are 24 by 10 feet.
That's time.
That's tiny.
Time.
Time.